on the eve of the Engineers Day, which was celebrated on 15th September. Engineers Day is the birthday of our great engineer, Bharat Ratna CM Vishweshwaraya. And we are conducting this program as a tribute to him. And today's topic is improving efficiency and effectiveness of manufacturing plant. This is a very vital subject and vital topic. And if you see globally and nationally, we have embarked on sustainable development growth. And we have got 17 aspects of that we have embarked on. And this efficient and effective manufacturing plant finds its place in most of these development goals. So this assumes great importance, this topic. We have with us three eminent speakers. Mr. Ashok, who is going to touch upon the energy aspect and how we can improve the efficiency and effectiveness of a manufacturing plant. We have Mr. Balamurugan from TG Bangalore, Toyota Group, and he will be dwelling on how to maintain the equipment and have better utilization so that we achieve effective and efficient manufacturing. And Mr. Ganesh will be touching on the various methodology and tools by which we could improve the efficiency and effectiveness of a manufacturing plant. All three are eminent speakers with wide experience and in-depth knowledge of the subject, and we hope we'll get a lot of ideas from them. So they'll be speaking for about 10 minutes, and I request all the participants, all the people who are attending this virtual program to put their questions, if you have any, on the chat box. And after the end of the three speakers' speech, we will discuss about these questions and any other discussion we have. With this, I request Mr. Ashok to start on his presentation. Over to Ashok.
Thank you.
Yeah.
Thank you. I'll just share my screen. Huh?
Yeah.
Okay. Is my screen visible now?
Yeah, sir.
Yeah, okay.
But we should make it big.
It is still not
full view.
It is still not big, is it?
In the bottom, you have to put this one.
Yeah,
slide.
you have to make it full screen. Yeah.
Okay, 1 second.
Full screen, you can select.
Equipment efficiency and energy aspects. There are two types of auxiliary consumption, energy consumption, and utility consumption. So when you see in the industry, what is happening in the auxiliaries and what is happening in the utilities. In the utilities, we concentrate on conservation and thereby try to reduce the units in the electricity consumption or the energy consumption in the utility. Whereas when we are going to optimize the auxiliary outputs given to the production machine, there is a basic difference where you find in the auxiliaries and the utilities, we can optimize the auxiliaries so that we can get the output, maximize the output and improve the total machine efficiency sustainably. And that's why this will also try to see that the kWh is reduced, and for the given equipment as a system, the specific energy consumption definitely improves upon this. We will develop on this. Basically, the total energy consumption out of which the auxiliary and utilities we are bifurcating and we are monitoring separately, and then we are seeing how much this can be improved upon on a finer way. If we see the why it is to be done means the T&D loss, what is happening in the national T&D loss around 20% means this is happening in the industry also. For every 100 units of your EB incoming, only 30 units is reaching to the ultimate process auxiliary or in the production machine or in the production utilities. We have a scope of energy efficiency at the transformer, at the motor, at the bearings and couplings, or at the linkages, power transmission linkages, then on the pumps, then on the control valves and the piping network, then comes to the process auxiliary, the heat exchangers or auxiliaries or production. Here if we find there is a scope, thanks to the latest 5-star ratings for all the equipment that is not coming in the domestic side, but it is coming on the industry side also. We have this IE3 and IE4 motors. They are taken up almost many of the new industries or the latest industries. They have gone for this, going by the National Motor Replacement Program. They are able to replace when all these 10 HP motors, they are able to improve upon it. Then coming the power transmission, many industries are leaving away all these V-belts and other things. They are going for these cogged belts and resizing their pulleys to improve the power transmission from the motor to blower or to the pump. Then comes the control valves or the piping, where the scope is very much more, because we have pumped in so much of excess energy. The piping have already gone totally scaled and totally the line size has totally changed as such. If this also needs to be done, definitely the system improves a lot. This is what we see not only on the equipment efficiency improvements, on all the energy aspects of main subsystem and the individual subsystems. The total T&D loss from the incoming to the ultimately to the production machine or to the auxiliaries or to the utilities, this is improved. The T&D loss can be definitely be totally curtailed or curbed, and it will be improved upon as such. Coming to the basic utilities or the auxiliaries, either the pumps or the blowers or the compressors, we can see the optimum system efficiency on the given pump, especially on the water transfer, on the cooling water application, especially on the chillers or any of the equipments where you are using this for this cooling application meant for the heat transfer. The velocity or the flow rate is very critical, where you can see the pump reliability. We have a model wherein the pump curve we go by that, and we see the reliability curve, and we achieve a system improvement by going for the best practice or the ideal practice or the better practice, where you can see the low bearing life of the pump, cavitation is less, and the pump curve is the best efficiency point of the pump is maximum utilized, and taking care of the reliability also. This is not only for the case of pump, it includes the pump straighteners, pump suction strainers, and the delivery, where the input output pipings also for the pumps also matters. So replacement of pump alone is not important now. The total system which is able to the matters, that is the monitoring the parameters of the suction and the delivery, this also is mattering to the pump process application, especially whether it is delivering to the equipment or to the production machine. This can be seen as such. If you take the case of blowers, again here also the typical blowers what is running in the industry over decades, it is having only 50% of efficiency. Though the Bureau of Energy Efficiency says you can go up to almost 70 to 80%. On the existing subsystem itself, we can see the breakup of the energy consumption going by the Sankey diagram of the blower system. If you give 60 kilowatt, almost 92% across the motor efficiency. On the belts and pulley efficiency, it is said it is around 99, but in many places it is losing around 5 to 6% also. Then on the bearings and couplings, then comes the impellers. The impellers what you have selected before some 10 years back, it's a forward coupler impeller or a backward curved impeller, whether it is delivering the same flow rate and the static pressure. So if you find the ultimate cumulative system efficiency is only around 50%, only 50 to 60% only, well, there is a scope for improvement up to 20% is possible. So here it is not that we have to replace the total blower system. Even on the existing system, if you are able to reduce the subsystem or improve the efficiency of the subsystems, especially on the motor to IE3 motor, and on the belts and pulleys to going for the cogged belts with VFD drive combinations, this also improves the torque given by the motor to the blower, that is also getting optimized, and ultimately variable torque motors, especially on blowers and the centrifugal pumps and even the centrifugal compressors. RPM is a critical measurement where it can be done in the industry, not only on the motor but on the machines, where you can see what is the output level we are getting and how we can optimize at the input. For this, all these motors or say blowers or pumps or compressors, the ambient air surroundings, that is more important. If you see the relative humidity, especially in our Indian conditions, 50% humidity and 180% humidity, you can see the almost the kg of water vapor per hour for every 1000 meter cube per minute. It doubles, almost it doubles. So the cyclic and seasonal RH variation in the ambient surroundings between day and night and season to season, cyclic variation, this is making a big impact on the blowers or in the compressors, wherever they are in the cooling towers, where they are making use of the ambient surrounding temperature and RH. So there we have to take care and try to monitor this and improve the subsystem efficiency on the blowers and on the compressors and on the cooling towers. Coming to the compressors, if you see, almost the energy balance of the screw air compressor utility, derating of the system subsystem start from the day one, especially in the compressor house, where the derating happens. It's an accelerated aging, you can see it can happen to the compressors, where almost 72% the heat of this one compression, almost it goes through the oil cooler, and almost 94% of the energy intake is extracted through the cooling medium, and only you find around 10%, 12% of the compressed air is only going after cooler. So if you find the real output from the compressor is only around 12% of the compressed air, then we have to take care of the subsystem efficiency like air intake, what is the air intake temperature and air intake RH, and how much the air intake filter can choke or give a maximum delta P, that has to be reduced to, it has to be made as free air delivery at the air input at the given compressor. And also the part load efficiency of the compressors. Normally all the compressors, if you see as a package, if it is running at full load and a 75 kilowatt machine delivering around 500 CFM, means it is almost taking 95 kilowatt, because it is rated for 7 bar, still the total package is taking around 95 kilowatt. Here in many of the industries, they have started replacing the motors, especially from almost 75 kilowatt, they have replaced to 90 kilowatt motor, and they are able to save the energy. And if at all you are trying to buy a new compressed air system, go for a higher pressure and operate it at a lower pressure. This is also more important, because in fact a compressor is the most abused utility we find in the industries, where normally it is around 250 watts to 300 watts per CFM it is taking, the existing compressors, but the new compressors, new generation compressors are taking only 150 watts. Almost this is a drastic change that is happening in the compressed air area in many of the industries, and everyone is trying to look into it, not only on the compressed air leakage, not only on the compressed air treatment, especially from the source end to the delivery end, the distribution point, and also the part load efficiency. The compressed air generation efficiency is more important, and it is time now to have all this going for installing a header flow meter. It is going to cost less than 1 lakh. But industries have not gone for a compressed air header flow meter to measure what is the input and output system for the given system. It's a dynamic variable, especially a dynamic process variable in the compressor. So if this is monitored every shift and every day and every week or every month, you know, are you delivering are you delivering for the same CFM 250 watts, or you are taking only 150 watts from the compressor given motor. So input and output parameters very much matter here, especially on the compressed air also. So I am just touching upon outlining what are all the utilities we are using in the industry and how much the process equipments have consumed in terms of energy or water or chemical or raw material. So it has given lot of excess emissions also. So whenever the equipment is consuming excess energy, this has resulted in excess emission and waste in pipelines. See, especially a 4-inch pipeline which you have used over a decade, due to scaling it becomes a 3-inch pipeline. The friction coefficient almost goes to 3 times than the existing friction, this one. And the velocity meter per second, that is also mattering more. So when you are replacing energy efficient equipment in the industry, especially when there is a tariff hike happening in all the states of India, It is not only the replacement of equipment, that it is also metering the input and output feed piping also for the given compressor or the pump or blower. This also has to be looked into it, and it has to be corrected as such. Thanks for giving this opportunity. I am just closing within the time as such. Thank you.
So, Mr. Ashok, can I now request Mr. Balamurugan to do his presentation? Mr. Balamurugan?
Yes, sir. Yes, sir. I will do.
Yeah,
my
please.
presentation.
Let
Thank
us
you.
have your question.
So my screen is visible.
Yeah.
Yes.
Yeah.
Okay. Good evening, all. Thanks for IIP for giving me an opportunity to share the experience what we are having at Toyota Gose. Just within a short time, whatever I could able to explain on the practical basis what Toyota Gose is doing, I will explain and I will close it. This is the evaluation of maintenance strategies, what is happening globally in the market. One second. Globally in the market. And as a TJSIN, still we are around reactive, preventive, condition-based and predictive maintenance. Still, we are a long way to go for this prescriptive analysis, where it is basically with AI-based. But definitely by 2025, we'll be reaching that with respect to equipment, so that considering the skilled manpower in the future, this is one important factor for any maintenance. This is a slide which shows the basic necessary requirements for any maintenance activities. We call as the initial setting. Good machine preparation for machine smooth SOP. SOP is smooth operation. There are 4 factors that we need to consider. One is machine installation and setting. Any machine, when it is being installed properly, then at the initial stage with all the conditions, with all spec and confirmations, then the problem at the initial stage itself is very low. Only thing, the wear and tear, it comes into picture. So this plays a very key role. Here, the inspect setting circumstances to eliminate machine setting problem in initial for machine smooth SOP, machine component need to confirm one by one. Like how we confirm is safety, alignment, tightening, wiring connection, program parameter setting, servo zeroing, and a pneumatic hydraulic cooling system, detective device, and lubrication. This is the basic confirmations during machine installation. Next, when you see this graph where it shows the failure rate on y-axis and machine smooth operation time on the x-axis, after SOP, you can see the wear out of the machines. Here, what is that we need to do? This is for the used and carry machines. Once this stage, when it comes, how to take care? That is by specific preventive maintenance through failure mode effect analysis. So this is called expired part need to change, mechanical part wear out need to be changed. This we call as overall. This is the second aspect. And to do this, the skill is very important. How the skill development is planned for the members. This is the complete training, and this is the common skill. And this is the new skill, what is required. And what is that training that we need to impart for any equipments? It may be a PLC, it may be a servo training, because now IoT coming into picture, the maintenance member skill also need to be trained towards that. So speedy new skill development plan should be there for the maintenance personnels. And 4th point is spares, which plays a major role. Spare part and tool. For necessary spare part and tool should be considered in the order spare. The order spare part that cannot know trends such as electronic board and tool for support. This part replacement has to be done. And also the wear out which is less than 1 year or can interfere which interface with other machines such as Ganom, Robot, and Untool for other support. This also need to be replaced. So this comes as a spare part. So these are the 4 factors which need to be considered for a good maintenance equipment before we hand over for production, so that the problem will be less. And before the stage, we call as a design stage. This is what we follow: the work design, initial setting, circumstance control. One is on the initial, then useful time and the wear out time. Considering this as a factor, target is the smooth machine SOP, 0 setting mistake, 0 long-term repair. And what is the source? Feedback from previous project. Any new machines, of course, when we are buying for a similar machines, what is the reflections or equipment that we need to take based upon the previous equipment, what we failed to incorporate? That should be the reflection. Here from machine breakdown history, from equipment installation and standard of equipment installation standard, the new machine drawing and manual, technical confirmation, Yokothan based upon others. So this is the key point as a source which we need to consider for new machine spec. And when it comes to machine design and specification, issue machine design feedback by history and Yokothan. Same machine and portion Yokothan, like in terms of safety, machine infrastructure, requirement on design feedback sheet. This should be filled up. And next forth comes the discussion with PE, we call plant engineering and process design, and drawing confirmation by maintenance team, and issue problem punch list back to the design team. So this is how the PDCA works. And based upon that, the machine transfer installation happens. Map of EQ means equipment setting and check sheet for equipment setting. And this will have like a safety, alignment, tightening, wiring connections, program and parameters, servo zeroing, pneumatic and hydraulic cooling system, detective devices, and lubricants. From there, the cycle goes to machine inspection by follow-up, map and check sheet. And then it goes to issue, problem, and punch list and follow-up. This is like a PDC approach. From there, we take it to endurance test and troubleshooting and countermeasure by initial problems by MJ. Machine Jiritsuka is what we call. And then issue the punch list with a follow-up. In case, if it is okay, then preventive maintenance setting plan and a manual drawing and control list. From there, it goes to the maker information records. Then again, it goes to the source. So this is the cyclic, what we follow as a TGSIN for any new machine design and installation, what I explained in the earlier sheet. So this will give a good equipment for the organization and for the production. So with this base, what we follow at Toyota Gose is, this is, you can see we have a Kanban system for equipment. When a machine is being procured, ordered, when it has come to the site for installations, we have 4 types of Kanban: white Kanban, pink Kanban, yellow Kanban, and green Kanban. White Kanban is like before power on condition, the equipment confirmation. That is whether the equipment has come in a right shape, like even in transit, some damages can happen. So before pre-inspect, before like a pre-start of machines, this type of checking will be done. We have a checklist which I could not share now because it is a detailed check sheet. And pink is to confirm mainly the safety function check. That is, once after the machine is installed and confirmed by the project in charge, the safety function check will be done by the project in charge along with the safety department. And the yellow Kanban means this is tuned for production, where the trials will happen and the production trials will be fine-tuned. And the green Kanban means the entire function check and the quality confirmation. And finally, handover takes place with the proper PM check sheet and the quality confirmation. So any equipment installation speaks only about the final part quality. In the detailed the sequence of cycle, the equipment, starting from equipment installation, the quality of installations and the quality of activity, the quality of skill, everything is being visualized, evaluated, and then handed over to production. This is the system that Toyota Gose also we follow. And this is just an example. what we have. This is like this shows the, sorry, it is not clear. This shows the entire equipment installation schedule. This is the Kanban system. This is pre-white Kanban check sheet. We have white Kanban, then pink Kanban. Then we have the problem follow-up sheet, and then followed by many static checkpoints. Then it comes as a overall equipment safety means maintenance, like a PM check sheet, and handing over the machine to production and maintenance personnel. So this is basically to ensure the machine is being made perfect and handed over to the respective process owners. And this is one of the example of the PFS sheet we call problem follow-up sheet for any equipment new installations or for any equipment preventive maintenance. After that, what we do. Yes, for any equipment, first is safety is very important. This is we call as a stop 7+1. We call safety in Toyota Zero accident project. And I think most of the people attending the programs will be knowing about A, B, C, D, E, F, G, H. Just I would like to say what about A. A is actuator. Actuator means being caught or pinched in case of any rotating equipment. B means big or block, we call contact with the heavy object. It may be any tool moving, like loading of press tool or loading of injection molded tool, etc. Car, contact with vehicles. Inside a factory, we use forklift, towing trucks. So when we have a contact with vehicles, this is called as car. And D is drop. Any load slips from at a height, that called as a drop. And electric is related to electric shock, and fire is related to any fire. It may be an electrical fire, or it may be any other in paint fire or like that. And G is Gillette. This is any cut injury we called as G. And health is this is ergonomics related issue. So we take these top seven steps in equipment inspection, and also we ensure the equipment is properly handled, handed over with all these basic safety features, so that it is good for maintenance personnel and production when they handle the machines. So these are the few explanations. Since a short of time, I am skipping this. And any equipment, the Lotto system is very basic. This is our Lotto system board. Lotto we call as lockout tagout. Any equipment when going for maintenance, maintenance personnel should have the lockout system. He should lock out so that the control circuit is de-energized and he can enter the machine safely and do the maintenance work, and he can come out. And this is the sample daily check sheet for the Lotto board. Like when any person come in, he takes the Lotto along with him, and when he completed his shifts, either of the shifts, he puts back the Lotto and he enters that we call as in and out. So that this is the safety management system that we follow for all the maintenance personnel. And I request all the companies to have such type of system, because many accidents what we see is due to even though the energy or power breaker is just to switch on. For a bigger machines, a third-party entry is almost will be there. So this type of system should be there for maintenance personnel before entering the machine. And as a equipment, we call machine failure mold effect analysis. So this is very key important point. Here it is to avoid the future failures, standardize the maintenance method, eliminate force and natural deterioration, and identifying the actions on each failures, and control the maintenance performance through MTTR and MTBF. And these are the basic steps which has been executed for machine FMEA. Understand the machine function, identify the probable problems in machine, define and analyze failure causes for each, and study on each failure with preventive action, and execute when the breakdown happens. And this is one example, what we do for failure FMEA, that is for the machine: potential failure mode, probable causes, potential failure effect, and prevention method, and recommended actions. And we severity, we arrive on detection, occurrence, and prevention, and we categorize based upon the RPN rating. So this is just an example. I think most of the companies will be following. So this is the very basic step for any equipment maintenance, how we arrive on some basic predictive or preventive checkpoints. And this is the sample check sheet, like a preventive maintenance annual schedule plan, what we have. For any injection molding machine, there should be an annual plan. So this will be made before, like if it is January or February for the next financial year. and we follow the financial year for the maintenance, and this will be circulated across the production functions to hand over the machines based upon the dates. 90% it happens, 10% it may not happen due to the production schedules, but that will be catch up during any holidays. And this is the monthly plan. Apart from the yearly plan, monthly based upon the production volumes and based upon the any breakdowns, we will small changes will be there. So monthly schedules will be almost 99% perfect. And this is how we follow TGSIN, how we take care of monthly schedule plan. And when we go to the checkpoint, before we go to the check sheets, these are the basic minimum content that we need to have as a preventive maintenance management system. First is as a content we call as a machine contactor, that is relays or any electrical contactors. Objective is the contactor link and carbonized checking. Okay, here example I have shown as a machine contactor, but like this many other it may be a battery, it may be any other pump can be derived, but this bare minimum check sheet should be having this type of thinking way. So objective of this contactor is to contactor link and carbonized checking, frequency monthly or twice in a month or thrice in a month. This should be based upon the criteria. The company can have their own criteria inside in-house. So we have our own criteria for the PM checking of machine. It is not that every machine will be going for every month check. Some criteria is fixed. And the safety point check and the method, every area it is like a method, actual reading, check manually. Then sketch, where is the portion clearly noticed, where supposed to be checked, and tool, either in case of this multimeter, standard, what is the voltage, and action if NG, check the link for any carbonization replacement, and effect if not done correctly, electrical fire or arcing, and the data entering is monthly, weekly wise. Because why I have taken the contactor is, our target is zero fire and zero fatal. And due to contactors, many fire incidents happens in equipments. So we give more importance for electrical contactors in machines, relays in machines, and earthing resistance in machines, insulation resistance in machines, which is checked periodically. And if you see as other next preventive maintenance sample check sheet, we have a detailed check sheet, but I am showing just a sample check sheet. Here, if you see the timing belt tension measurement, here if you see the span, width, and mass is given, and what is the recommended Newton and what is the lower limit supposed to be. This is the basic which we arrive based upon the maker's manual or maker's recommendation. And this is one sample check sheet what I have shown. The data should be measured properly and should be represented in numbers. Sometimes what we do, we just check with the hand or some hammer and we say okay by entering a circle or X when it is not okay. Here point is how it is supposed to be a data-based approach where it should be a measured value for certain things. It may be an ampere, it may be like newtons. So this is the way of check sheet that need to be framed for equipments. This is one example. And next, if you take for as a pump, how we are monitoring, like every year, like when like example, this is a pump where we have a standard, and in 2018 the reading is like this, and in 2000 and we have pressure adjusted as per the standard. Then in 21 and 22, how we are monitoring the pump pressure. So like this, we need to monitor like this pump pressure. We monitor one time per year as a overall and health check. This need to be monitored to see whether the pump performance is okay. But nowadays, this has been converted into like a sensor based and AI based, and we are taking the data directly from the machine. So this is how the trend is changing. But these things need to be monitored to see, yes, the machine is not being pushed to break down, so that we take some predictive actions. And okay, this is just for the blowers. Like we have just started with what you call a vibration analyzer. This is already we have connected. We have taken the white system, and through a sensor-based approach, we are taking the reading. So directly we get the reading and we export the data and we make a graph like this. This we just started last month, and this can be monitored so that every time no need to go and check. Spend time on the blower maintenance. So many blowers we use in paint shop, so it is a very huge task. So based upon the data, we take actions so that the maintenance time can be minimized, and maintenance personnel also can be minimized. This is indirectly a cost cutting, but it is a digitalized data-based approach. Next, we call as repair step analysis. After experiencing big breakdown, analyze the current repair steps and mean time to repair. Then try to reduce the repair time for each step. Approach towards current repair steps to standard repair steps. What is root repair step analysis? Skill enhancement, MTT reduction, and training material for new maintenance engineers. This is one of the key factors that everybody should think, because a skill and knowledge based upon the experience is most important. So the steps involved is understand the actual root cause of the problem, list out the current repair steps, think about the repair step reduction, and compare with this corrective action and the standard action, and execute when repetitive action happens. And this is one sample check sheet, like before and after that, with what Kaizen point from 160 minutes to 80 minutes, so that this becomes the standard, so that the mean time to repair can be minimized. So to do this, the skill is most important. Any company, we should have a training need identification for the maintenance personnel on various aspects for the members. This is just a sample sheet what I am projecting here. What is the training task need across each members, and what is the current level today, and how they are going to reach in the year on, like today by 2022, if this skill is like this, by 24 or 25, what is the expectation and what is supposed to be. So this is how we monitor the members' performance with respect to maintenance. So I have touched upon up to training. Next comes as the spare parts management. We are into SAP. So whatever the spare parts we define based on VED analysis, vital, essential, and desirable. Based upon that, we make the list, and we will be ordering the spares with the reorder level, whatever we have defined, and what is the lead time, and it will be ordered directly through SAP when the stocks goes down. So this is the system what we have to TGSIN. And next slide, what it shows is energy monitoring and spot production monitoring system to improve OEE. Now OEE basically speaks upon productivity, quality, and availability. So if you performance, quality, and availability. Example, here it shows availability as 43%. On manual data, whatever we do, basically the lot of mistakes happens, or wrongly it is projected. We have made injection molding machines by connecting to cloud computing and taking the data. And for each products, we are having a QR code, that is inject printer QR code, and every product is being accounted through a reader, and it is directly been linked to SAP, so that we get the right production count, right energy reading, and right hourly monitoring. So when 43% if it is availability, then actions comes by the production, where is the problem and what actions we need to take. Most of the problems, everybody says maintenance issues, but maybe the planning is good, not good, or the member absenteeism will be there. So this gives the real-time data on where is the problem and how to act upon it. But this also gives the data on energy, like which machine is higher consumption, which machine is lower consumption, why per hour the production loss is there. So this type of data we arrive, and this is one example how we arrive on the units per kg for injection molding machines. This is like 4 machines what we have taken as an example and projecting here. The target is 0.35 units per kg, but what actually it happens like this, and even on Sundays some units been consumed. So this is called as low hanging fruits, where we need to project to production guys and inform why the machine is simply on Sundays. That should be the first step. Then when we fix a pattern every day, like Monday, Tuesday, we have a standard pattern, not every day different mold changes will be there. We have a pattern. So when first is Monday, if it is first Monday, again, the 6th or 7th, it should have a same energy consumption. Why there is a variation? So this need to be analyzed and inform production, what is the downtime? So this type of data need to be utilized to take corrective actions. So this is the current how we are moving on, and this will improve the efficiency and OEE. This ends my presentation. Thank you. Thanks for the opportunity. This is just a few slides I have shown on improving the maintenance. Thank you, sir.
Thank you, Mr. Balamurugan. Now I'll request Mr. Ganesh to have his presentation. Mr. Ganesh?
Yeah. So first he has to close it, right? Okay. Fine.
Balamurugan,
No
you have to
problem.
exit the
Yeah.
screen share.
No problem.
Balamurugan?
Is this one is clear?
Yeah.
Yeah.
1 minute. Is it okay? Readable?
Yeah. Good. You are coming
Okay.
full screen.
Good evening to everyone. That is, for giving the opportunity to do the presentation for celebrating the Engineers Day. In fact, the time available is very limited. I have actually prepared for a longer duration. So I'll be skipping some of the slides, right? Even though I wanted to tell more due to the time limitation. So sorry for the inconvenience if I skip some slides on that one. So the idea of is improving the efficiency in manufacturing plants. Like today's topic theme is challenges in the efficiency in manufacturing plants. What is the challenges? So let me go into that. So basically, before we understand what is this manufacturing efficiency. So manufacturing efficiency is achieved when you create a products with the lowest possible total cost. It's all about creating as much as you can with the resources that you have while reducing the time, material, and energy which you waste. That is the basic of the what is manufacturing efficiency. So it can be calculated by means of a standard in terms of actual output to the standard output, and the ratio will give you the efficiency. So what are the basic challenges? What do you have? So one is basically on the forecasting demand, controlling inventory, improving efficiency at manufacturing plants, increasing ROI, skilled labor shortage, managing sales leads, coping with the new technology as we come into more of a competition from different manufacturers, how we have to be in line with the competition. So first, basically, I would say overall a system has to follow certain overall standard as well. Like I prefer ISO 9001:2015. Quality management system gives you a very good guideline to ensure how you can set your whole the activities right from the time to the final product. Delivery. So it has got a basically we have to ensure the process procedures, flow charts, operating control procedures, SOPs available for how you have to do various activities. There has to be a top leadership commitment and respective unit heads, and role responsibility have to be very clearly defined so that they know what the job they have to do. There is no any conflict of work activity. And for to improve, there has to be objective and target. We have to set the targets so that can give guidance for achieving certain set targets in terms of reaching the in terms of quality as well as progress as well as no defects like that. Risk assessment is again a very, very important parameter. We have to know during the entire process of our manufacturing what are the risks actually there. We have to assess the risk and what is the mitigation plan. Communication has to be made very clear so that who will communicate to what and what extent. And there's another important parameter is internal audit and management review. So we have to do a complete thorough audit of the entire process. What are the various drawbacks and what are the non-conformance to the set procedures. And finally, the improvement part, what we have to do for the next this one. So the basically is let's see how to improve the manufacturing efficiency. So these are the standards for applicable to all types of industries. If we take any industry, process industry or product or any other aspects, we can see these are the ones. First is don't waste material. Waste is a broad term and can refer to material, energy, man hours or space, etc. Improve the training, quantify everything. Whatever we do, we quantify those things. Organize. We have to be clear in what are the ways in which we have to implement these aspects. Standardize the work, implement cellular manufacturing. I will give you the detail what it is. Proactively manage equipment failure. So we have to do as what the earlier speaker was telling about the preventive maintenance. So we have to know proactively how we manage the failure this risk assessment will come into a good handy for to foresee what are the failures which can happen. Strengthen your supply, that is all our supporting other service providers, the suppliers, vendors and contractors. So how you have to have a very good link and relations so that they provide you, because these are all the extended arm of your manufacturing. So they have to have a very good relationship to ensure that your components or other service are available at the right time. So the winning, well, I just kept that one. So this also I'll put. So basically, where are the different process which is there? Normally in automotive industry, we use Kaizen. Kaizen, which is a very common term used by Japanese for continual improvement. This lean manufacturing tool dictates a process to be continually improved in order to eliminate the waste and boost efficiency. So in the automotive industry, Kaizen is often implemented in order to address the problems and provide solution in the assembly. So there is a bit difference between continuous improvement and continual improvement, because there is a commonly used in different ways, but continual improvement is the improvements goes by means of a steps. Whereas continuous improvement is a continually improving, which may not be possible. So we have to reach a certain level of a target by over a period of time and go to the next level by means of engaging additional resources or the different manufacturing process. So this and all I will just skip. So this is the continuous improvement method employed to identify opportunities for streamlining work and reducing waste. It covers ongoing development of products, optimization process, streamlining of services in order to the name employed continuously improving your operations. How can see particularly in food production industries, which are the more important thing is innovative instruments, digitalization, maintenance and cleaning, which is very become important due to the hygienic conditions, and optimization to reduce cost and increase productivity. So I'll just touch upon all the various factors which we said that the challenges. First is the don't waste material. In terms of waste is a broad term and everybody knows that one. So Lean offers a set of tools to help manufacturers actively improve efficiency through systematic reduction of waste. So many of the above ideas are linked to lean manufacturing methodologies. So here I will give you the basic description. Later we can see into the actual block diagrams to understand better. So next is we focus on the design material waste, because design is a very clear, important aspect in which we can ensure that waste is become very less, or we can avoid the waste also. Designing parts using methodologies by means of using a design for manufacturing, manufacturability can drastically improve the yield. Recycle scraps, like as we see, is how to use the certain materials which are can be used for some other purpose, so that we can avoid the wastage as much as possible. Even if you cannot use the recycled material, you can sell it to a factory that can, where other organizations or manufacturing can use it for their own internal as a raw material. Optimize the process to utilize all available material. So we use the more sheet metal before scrapping. Can these tool tips be sharpened, reused instead of discarded? So these are the questions which will come during that process. So you have to ensure that optimizing the process will avoid the wastage. And basically the other is look at the shipping department, where we have to ship the materials or the transport of there. If we can able to manage it in a better way, so we logistics or supply chain management we have good there, then we can avoid a lot of wastages happening, or the energy efficiency which will go into wastage of this transportation. So second aspect is the improved training. As with training comes very important there. So when we say training means we have to ensure the people or the employees competent to perform their jobs. So when you say competence means he is quite knowledgeable and able to produce the desired or intended output as what is needed. So that kind of a training is needed. So we have to give, take stock of, we have to understand what is the employees' present strength and what are their, understanding of doing their jobs. So find out why they can help one another in troubleshoot. Also, these employees who are all well experienced can also form as a group to find out what are the ways in which they can improve the efficiency of the activity, what they are doing it. If everyone on the factory floor has a good grasp of entire process from start to end, they'll have a better understanding of the rules. Next is quantify everything. So whatever we are doing, assign a point of value in terms of every aspect of a manufacturing process. Material costs are obvious, take into account of man hours, equipment wear and tear, and planned obsolescence to further quantify the production. By assigning numbers, you are able to get a better control of how to take care of that, where it is going more than our planned requirement, and wherever the extra is coming, or the time in terms of time also. So organize everything. Organization is a key into efficient workspace. So take a look around the factory and basically the layout and the tools, different methods like time management and process management, or handy tools to find out waste products piling up in the corner. Suppose we find a lot of waste products piling up. So we have to find out what are the causes, root cause for all those things. All tools, parts, and materials and instructions should have a home and everything. So we have to identify where is the location so that it need not have to be searched or lost in the aspect of manufacturing. Standardize the work. Everyone has the work. See, when you say standardize, already I said in the beginning, the ISO system gives you the proper process procedures, and which will define what are the each activity or the process needs to be defined very clear in terms of the aspect of manufacturing, in terms of the testing, in terms of the tools required, in terms of instruments. And when you do the testing, what are the limitations or allowable limits, so that whether it is exceeding or below that, that has to be taken into account. So standardize the work. There's a lot of room for individuality. Even the simple task should be standardized to maximize the efficiency. Start, what is the method? We can make a checklist, placing it in each on workplace. Then make sure every employee does the job in the workflows as per the checklist. Then it is just another one aspect of improving efficiency, cellular manufacturing, which you say the cellular manufacturing methodology involves dividing the workspace into cells and assigning each cell a standardized set of tasks. Machine and employees, each cell might be capable of carrying out a wide variety of jobs, but allowing them to focus on a single job process. So this is another way of doing an improvement. And proactively manage equipment failures, which is said that before the really any equipment fails, like we should avoid as much as possible the breakdown and attend to reactive. So if we go into a, like we all know that toothbrush is a lot of cheaper than a root canal, but not everyone carries the wisdom over to the manufacturing. So preventive maintenance is the practice of performing maintenance tasks based on the known schedule of wear for a particular tool. The idea is to provide maintenance before it is necessary, but not so often it interferes with the other tasks. Decide on the right schedule by consulting tool manufacturers. Then strengthen your supply base. As I said that when you quantify your manufacturing process, be sure to take a close look at your suppliers. Notice some are consistently providing a better material, parts or tools, give them the more business. There's another place where quantifying comes into handy. Sticker price, hardly even accurate indication of the true cost. So, and also we have to look into the supplier base in terms of their cost, in terms of their quality, in terms of the timely schedule, in terms of giving a very good communication and supporting you for any urgent needs. Engage your employees. So what one is the training we have seen, another is the process of how to improve the efficiency is the people who are really on the shop floor, on the plant area, who has got a very good knowledge, would have got a very good experience in managing that. Give them the open space for them to share their ideas and thoughts. So if a process plagued by downtime, look to your employees for answers. So it's only logical that a person responds carrying on the job might be having a better ideas. On the hand, easy for executives and managerial staff who are used to looking at the bigger picture to miss smaller opportunity for improvement. So it is important to open channels of communication so employees can effectively. So we have to have a, like we used to go for a quality circles in the shop floor area, where the group of people will be together discussing and trying to give their thoughts and ideas for any solutions for any problems which they face. So this another one is this, what is another method of doing it, that is O for operate, and that is operator would check the performance of support software and track, and the target units need to be produced, that is a tracking. Identify operator would then report the issue with the production, a certain missing parts or other components. Then a technician would then see the downtime reports, machine filters not available. He then comes with a solution. During the setup, make sure that there are at least 3 replacement filters before running it. So it is a solving. The finally is a transferring the knowledge. Whatever you have experienced or gained should be used in the future so that the same issue or problem does not reoccur. The solution have extra filters during setup is immediately added to work instruction. So we have to put it into our system practice or in the procedure. So this another way of doing is a continuous improvement. First, we already said that what is a continuous improvement. So we can use in the process improvement lean technology, where the Toyota has been utilizing it for well. From there only we get to know very popular it became. Improvement customer focused. Then other is Six Sigma, is a method that focuses on improving the quality of business process, limiting the variation process to ensure consistency in production. TQM is a similarity to Six Sigma and holds all involved parties responsible for producing a quality. So everyone becomes, so the entire, right from the top management to the last level of the employer is responsible for the total quality of the entire manufacturing process. So example, we'll just see a certain few examples before we go into that one. So we had to do a survey and people who work with the organization are most well-versed. So I already told in the earlier this one topic, by taking your care of your people, their involvement can give you a better this one. Then it is common that each employee works with a silo or sim. Suppose if he is working as an individual, so we had to use a cross training with automation software. So they may be doing it in a certain activities in their own way for a longer years. But we have to see, we want to improve the efficiency, then we have to go for certain automation. Those people have to be trained into that one. So time audits, we have to look into every activity. What is the time which is being taken, whether there is any hold up time, whether the employees idling anywhere or the machines idling anywhere. So these things will give you a scope for further improvement in the efficiency of the manufacturing. Then this is another aspect. Catchball is a method of continuous improvement that requires a person who initiates the process to state the purpose and concern to others involved clearly. In this way, we can throw it out to the group for feedback and ideas for improvement. Yet the single person remains responsible, even though the person is totally responsible, but he takes the feedback from other co-workers or employees to get some better idea to resolve it. So here is some breed of waste with the business, which we are normally aware of that. Timeliness, system downtime, errors, manual data error, people underutilized workforce, excessive management, production, overproduction of printed document. So these things will become a basic this one. So we go into the whatever I explained, I'm just putting it into a little more visual effect in finding out Lean Six Sigma DAMAC. You say define the problem, measure quantify the problem, analyze what it is, improve on the problem, and control, maintain the solution. So that is Lean Six Sigma DAMAC. Then we have a customer satisfaction. These are all the lean manufacturing tools, which is very popularly used in different industries according to the automobile or other process manufacturing. So mostly we take it from the Japanese system, where it's all well utilized in Indian organizations also. Total 8 ways of lean manufacturing, which we discussed there. You can see in form of a pictorial form, where the transport is giving, inventory, piling up, motion, where there's a time delay, waiting, idling, overproduction, which you've seen that one, over processing, defects, whatever the defects which we come across during the manufacturing, unutilized talent. The people are all quite good talent, but they are unutilized, not able to get their full efficiency in using for better manufacturing. So this is a lean process improvement. So these are the 7 normal waste which we have already discussed in pictorial form, where we have to see overproduction, inventory, transportation, motion, weighting, and defects and over processing. So this is a TQM, total quality management. So the first thing what it starts is a focus on customer. That will be the key, because the entire business is depend on the customer. Customer is always right. So we have to ensure that customers' needs and expectations are satisfied by means of a TQM, by ensuring employee involvement, process oriented, integrating all the systems, systematic approach. We have to do that one. So here decision making based on facts. This is a very important aspect. Like this is whatever the areas or any issues or problem, we should not link that problem to a person. So it's not a person based, it's a system based. So anywhere any issues or problem arrives, there is a lot of a blame game goes that will completely spoil the entire manufacturing process. We have to find out why that this issue has happened, what way the system has to be improved, so that the concerned person is well aware, and so that these things will not get repeated. That's why the communication, which I told, this has to be very important. So wherever the communication matrix for the every levels of people have to be clearly identified. Finally is the continuous improvement, so which has to take place, so that it is a cycle which goes into that, which we normally say PDCA cycle: plan, do, check, act will be there. Then the Kaizen approach, which we seen that one, brainstorming, measuring, comparing that one, innovate, standardize, and repeat. So this also goes into the continuous improvement. There are various lean manufacturing tools are there. Each organization, according to their need and requirement and size, they use the different type of lean tool. Then there is also another way in which you can identify the problem is a 5 whys. If any issues there, we have to go into root cause problem. Root causes by means of analysis of a 5 whys. So finally the last why will identify where is the root cause, so that once you separate the root cause, then this problem or issue will not get repeated again. So 5 is the lean manufacturing: sort, straighten, shine, standardize, and sustain. So this is also is a very good way of ensuring the lean manufacturing. Then lean tools are available, various aspects, just in time, visual management, right first time. So always we do the work, whatever it is doing the right first time itself, we are doing right. There is no question of defect taking place and again rework is there. So to avoid rework, then every engineer finds solution for problems to ensure improvement. So engineers becomes the backbone for the entire manufacturing process for improvement. Thank you.
Thank you, Mr. Ganesh. So we had a very interesting and very informative sessions from Mr. Ashok, Mr. Balamurugan, and from Mr. Ganesh. Ashok stressed on the various energy aspects of the utilities and the ancillary unit, and how they have to be monitored, and how the new generation equipment will be more energy efficient. Balamurugan was explaining the bathtub curve, the initial setting period, the free and problem-free running period, and then the decay period and the refurbishing stage. And he was telling about the various systems they have followed in DGSIN. He also stressed on safety aspects in an equipment and the various methods of maintenance, preventive, corrective, all those methods, to ultimately to see that the uptime is guaranteed and reliability is ensured. And Mr. Ganesh stressed on the cost reduction through waste reduction, using the various tools like lean tools, Six Sigma, 5S, TPM. And he also stressed on continued improvement and TOI, total employee involvement and training. He briefly explained about the various tools which can be utilized, and the need to system-based management, so that we have cost reduction through waste reduction. So with this, I would like to put the floor to the participants. Any questions is there, they can ask.
Camera is not on, sir, please.